Hi, welcome to clickmyproject.com. Now we have to see the process of holistic Topk simple sorted path join in graphs. Here is the abstract of our process. To propose holistic method of Topk join strategy for group length system analysis. Here the name Topk join path discovers the Topk shortest path between given node sets. Here, rather than discovering the Topk simple path between each node path, it proposes an efficient method to find the constrained Topk shortest path between the two virtual nodes. And also, specifically, transform the graph by encoding the pre-computed shortest path to the target node and use that transformed graph in the candidate path searching. And also, it is used to reduce the cost of candidate path searching. Here we use two optimization strategies techniques using Topk for further improvements. So that the optimization strategies are push join constraints and also the pruning search page. And the push join conditions in the candidate path search denotes the deviation node and process the next step. Then pruning search page is considered with determined threshold values in candidate path generation. Here is the flow diagram of our process. The first one is creating node. Here the node creation process. The nodes are created based on our Florida datasets rules. Then moves to graph formation. Here the graph formation, the graphs are denoted based on the node creation, age, cost and weights values are created in the graph formation. Then moves to pre-process. In graph pre-processing, we have to apply the cost of each node in that graph formation. Then goes to the apply holistic Topk join method. So to calculate holistic Topk join method, first of all we transform the graph by using pre-post parent method. So the transformed graph is given as the input to the holistic Topk join method. In holistic Topk join, we have to find the shortest path, so that we have to use two optimization strategies, that is push join constraint and pruning search page constraint. The first one is push join constraint. Here we find out the deviation node from the transformed graph of the node creation. So here consider as a deviation node as a source node. To find out the shortest path between the source node, that is deviation node, to the target node. So here ignore node set and ignore node creations are calculated done. Then moves to apply pruning search method. In pruning search method, we have to calculate the threshold value of the transformed graph. That threshold value is based on the maximum length of the node process. So the shortest path is calculated below the threshold value. So the pair of path is computed. Finally, merge the process. So the push join shortest path and pruning shortest paths are merged. So finally, we validate the simple shortest pair of paths between the source node and the target node. Here is the demo of our process. By clicking node creation process. So the nodes are initialized first and the initialized nodes are drawn. So the nodes are first initialized. So the labels of the corresponding nodes are denoted based on Florida datasets. So the edge is denoted, then connection. Here the graph is shown. Then provide the connection. The edge codes are denoted by clicking direction. The direction of the node is denoted. Then moves to pre-process. Here the graph is transformed into the transformed graph. So here is the source node, that is the target node. So the transformed graph is created in that process. Then we apply our technique. Here we are going to construct a transformed graph. So by clicking on graph, it denotes the original graph process. So that we have to add a source node and target node. Initialize the cost is 0. Then apply Digital's calculation. So the shortest path is found based on Digital's calculation. So the result is these are the shortest path calculation based on the Digital's calculation. So the transformed graph is displayed. Here the transformed graph. So that graph, these are the shortest path calculation based on Digital. So we have to transform the graph by using our holistic method. So that structure labels are denoted for the transformed graph. So the costs are also calculated for the transformed graph. So here also the holistic transformed graph is shown. Then moves to the deviation process. In deviation process, we calculate the deviation. The deviation node, which node has a high branch nodes, those are denoted as a deviation node. So we have to find the shortest path. So we calculate push join method. We have to consider ignore node and ignore edge. So these are the nodes of ignore node and the ignore edge. So that compute paths. So the path are 24 and 20. So that we have to move results merging path. So there here the before the deviation nodes of the path and after the deviation nodes of the paths are merged. So the holistic join path. So the holistic join path denoted the merging process. Then moves to push join process. Here the push join process, the join constraint is 24 and 20. So we have to verify the simple shortest path by clicking verify. So under the source node hatch is the deviation node. Here we consider deviation node as a source node. So under source node hatch the verified path is 20. Then move to the pruning search space. Here the pruning search space we have to set the threshold value as 24. So below the paths of the threshold values denoted 24 and 20. Here we consider two policies, eager and lazy policy. The eager policy denotes the we have to search the extra path in that method is called eager policy. In lazy policy, the normal path search is called as lazy policy. So by clicking lazy policy, by clicking result process, the result of the lazy policy are calculated and displayed. Then moves to eager policy. Here in eager policy, the extra paths are calculated by using the eager policy. Here the threshold value is set as 24. The 24 denotes the maximum length of the transform graph process. So we have to deviate the patterns in the process. Here the paths are computed successfully means. So the push join constraint path and pruning search space paths are computed. So that we have to contain the three paths. So the computed paths are 24, 20 and 21. Here the threshold value is denoted as 24. So the finally validate path means so below the threshold value the paths are calculated. So our shortest path is 20 and 25. So we have to find the holistic Topk joint shortest path. Thank you.